Okay, this is the answer key or the notes guide to Chapter 3, final review for Algebra 2 honors. We're starting with graphing parabolas. So, graphing parabolas, pretty straightforward. When we look for up, down, left to right, we're looking if x is being squared or the y value is being squared. That tells us that. And if the a is positive, it's going to go up or to the right. Right. This would be a is positive. This would be a is positive, and then down would be a being negative. And oh, I got this wrong around. This is a is negative, and then this would be a is positive. Okay. So it's going right. A is positive. Up. A positive. Down. A negative. Left. A negative. Okay, so we know it's going down. Y and x-intercepts, f of 0. That's how we always get the y-intercept easy, right? And that's just 8. X-intercepts, we are going to take out that negative. We're going to get x squared minus 2x minus 8. And then we're going to factor this. We're going to get x minus 4 and x plus 2. So that means my x-intercepts would be x equals 4 and x equals negative 2. 1, 2, 3, 4, 1, 2. Okay? F of 0 is 8, 1, 2, 3, 4, 5, 6, 7, 8. So we're getting a picture of what this parabola looks like. To get the vertex, there's two different ways to do that. Well, there's multiple ways, but to know would be it's negative b over 2a comma f of negative b over 2a, right? So that you get from that standard form, or you can make the conclusion that the vertex is halfway between the zeros. So it's p plus q over 2 comma f of p plus q over 2. Okay. The midpoint between negative 2 and 4 is 1. So that would mean your vertex is 1 comma, and then we'll plug in a 1 and we'll get a 9. So 1, 9 is your vertex. And then we can sketch. If we wanted to get the focus and directrix from here, usually you have it, well, you have in conic form. We don't have in conic form right now. To get in conic form, we would have to complete the square and write it in vertex form. We do have the vertex here, so we do know that the form would be y minus 9 equals negative h minus 1 squared. Okay. When we write it in conic form, we have it the other way around, the way we learned it anyway. So it would be x minus 1 squared on the left. We're just going to switch these. And then on the right, negative y minus 9. So if you remember, the focal length, this value here is 4p. So that would mean that your p would have to be negative 1/4. So your focus would be f would be 1 comma 8 3/4. And the directrix would be y equals 9 and 1/4. Because we're going to add and subtract p from our vertex. That's what's going on here, right? So we have like a focus just below here, and then the directrix is just above here. Okay. All right, down below. This one's written in vertex form. The way that we learned conic form for parabola is that the squared term was always isolated. So in this one looks like it's good to go, but really this x squared term should be on alone. And then the y minus 3 should have the coefficient. So we're going to rewrite this. We're just going to multiply both sides by 8. And we're going to write it as x plus 2 squared equals 8 y minus 3. Okay? From here, it's pretty straightforward. So vertex, we can see it's negative 2, 3. What else? We have the y-intercept, so that's just f of 0. That would be easiest back in this one. We'll get a 3.5, right? 0 plus 2 squared, it's 4. That's 1/2, then plus a 3, 3.5. So 1, 2, 3.5. Your p here, because that's an 8, your p will be 2. So that means that next should be negative 2 comma 3. My focus would be negative 2 comma 5, and the directrix should be y equals just positive 1. Okay, so here we got directrix here, focus here. And we can start to sketch. We also know that the focal width would be 8, so this must be here. This must be here, and there we go. And when it comes to x-intercepts, there are no x-intercepts here because it doesn't touch the x-axis. What you would want to do if you were going to try, if there were x-intercepts, you wanted to find them, you could just expand and rewrite this in standard form. And then you could use quadratic formula, you could use factoring, whatever, to get those x-intercepts. Okay, dividing polynomials. We remember dividing polynomials. So we have two ways to do it. There's long division and then there's synthetic division. The synthetic division is the faster way, but it only works in certain situations. So for our polynomial long division, you set it up just like you would a classic long division problem from elementary school. You have inside 4x squared minus 3x plus 1, on the outside x plus 1, and you ask yourself, what is the largest term I would multiply x by to get 4x squared? And that's just 4x, right? 4x times x is 4x squared, 4x times 1 is 4x, and then we just subtract down. So we get these cancel, and then we have negative 3x minus 4x is going to be negative 7x, and we drop down that 1, and we do the same thing. What times x is negative 7x? Well, it's just minus 7, minus 7x, and then we're going to get a minus 7, and so we'll end up with this 8 remainder. This is your remainder. So our answer is 4x minus 7, remainder 8. The way that we write that is 4x minus 7 plus 8 over x plus 1. Okay? Synthetic division only works when we're dividing by a linear term, right? This is a linear term with a degree of 1. If we had a degree of 2, you could not do synthetic division. And if you want to always use long division, that's fine. So on the outside, we actually put the 0 here, not the factor. So we're going to put negative 1 there, and then we're going to put the coefficients on the inside, 4, negative 3, and 1. We're going to drop it down. 4 comes down. 4 times negative 1 is negative 4. Add negative 7. Negative 7 times negative 1 is 8. No, 7. 7. 1 plus 7 is 8. I was jumping ahead. So we end up with 4x minus 7, remainder 8, right? These terms here are 1 degree lower than our original. So this was an x squared, now it's an x. This was an x, now it's a constant term, and so on. Okay, so we get the same answer for both. Graphing polynomial functions. Okay, so if the degree, let's review degree. So degree is largest power. That's important. So for the shape, if you have a positive x to a odd degree, it will end in different directions, but one will be, the left side will be decreasing and the right side will be increasing. If you had a negative x to an odd power, it would be the opposite, so something like this. If you had positive x to an even power, it would be both sides up, and negative x to an even power, both sides down. Now, what happens in the middle, we don't know, but we know how it's going to end, and that's the end behavior. The y-intercept is always just plug in 0. So in this case, it's just negative 12, pretty easy. And then the x-intercept roots, we'll get to that in a moment. Let's start by just graphing. Let's look at this problem. So it's going to end increasing, and it's going to go up to the right and down to the left. I know that because the degree is odd and it's a positive leading coefficient, so it's going to follow this rule. I know that my x-intercept, sorry, my y-intercept is 0, -12, so right here. That's not a lot. Let's get the x-intercepts. So the x-intercepts, you need to know the possible rational roots. Remember this? Possible rational roots are the factors of the constant divided by the factors of the leading coefficient. So in this case, -12 is my constant, 1 is my leading coefficient. So this would be, my possibilities would be, they're all over 1, right? So it's going to be plus minus 12, plus minus 4, plus minus 6, plus minus 2, plus minus 3, and plus minus 1. Okay, a lot of different options here. And then to find them, you test these. So you plug them in one at a time. I would not give you a problem on the final that was like this, where you're chugging away, plugging in 1, -1, 3, -3, and so on. I'm not going to give you something like that. It might be like I could give you it, but it might just be 3 possibilities, something more reasonable. Especially since you don't have a graphing calculator, right? That's going to be challenging. But if you went through them, you would find eventually that f of -2 is a 0, right? So by trying, you would see that f of -2 is 0. And once you get one of them, then you know what to do. You divide by that 0. So we would do long or synthetic division, 1, 3, -4, and 12, and then -2 on the outside, and we're just going to drop 1 and -2, and then 1 and -2, and then -6, and then 12, and then 0. So we'd have x squared plus x minus 6, and we can factor this. We'll get x plus 3 and x minus 2. So that means my zeros would be x equals -3, -2, and 2. Okay, so -2 was the guess and check. Then by dividing it, we factored and we saw that -3 and 2 were the other zeros. So -3, -2, and then 2. Okay, and then the rest of this you can do different ways. We know how it ends. We know that it must be going up here because it ends that way. We also know that it must be going down here. And if you see, like, it has to hit this value, so it has to come down here, and then it has to come back up here, and then it has to wrap back around there. So you can intuitively figure out how to sketch it. You can also do a number line where you draw it out and you put all the numbers, -3, -2, all your zeros, and 2, and you test numbers in between. So you test a number above 2, like 10, you would see that it's positive. If you test a number between -2 and 2, you would see that it's negative. Between -3 and -2, you'd see it's positive, and below -3, you see it's negative. And that would tell you whether it's positive or negative in those regions. Okay, that's graphing polynomial functions. Rational functions. Rational functions. So, rational functions, these are fractions, right? We have some polynomial on top and some polynomial on bottom. That makes it rational. Let's start with wholes and vertical asymptotes. So these happen when you have the same factor top and bottom. So let's say you had x plus 2, x plus 3 over x minus 2 and x plus 2. Okay, so if you were to plug in a -2 into this right now, you would actually get 0 over 0, which is an indeterminate form. When you have the same factor top and bottom, you have a hole at that value. So our hole is at x equals -2. Okay. To find the y value, you cancel the hole and then plug in that x value into what's left over. So left over would be x plus 3 over x minus 2. Plug in the -2, we're going to get 1 over -4. So your whole coordinate would be -2 comma -1/4. Vertical asymptotes happen when it only occurs in the denominator. So we take that same example, x plus 2, x plus 3 over x minus 2, x plus 2. Okay, we do have that whole at -2, but right here we have a vertical asymptote at x equals 2 because it's a 0 only in the denominator. Okay, this would be a VA, a vertical asymptote. Okay, for horizontal slant asymptotes. Okay, so basically you look at the power of the top and bottom. So let's say you have the degree, 3x squared over 2x squared, and then the rest of this is like whatever, 3x plus 1, doesn't really matter what the rest is. You look at those two leading terms. If they're the same degree, top and bottom, square and a square, it's the ratio of their coefficient, which is the horizontal asymptote. If it's bottom heavy, so let's say it's 3x squared over 5x cubed, and again, this can be whatever, you look at these two, and if the bottom wins, it's 0. If the top wins, so it's the other way around, let's say it's 6x to the 5th over 2x squared plus 1. The top wins in this case, there is none. Okay, slant asymptotes happen if degree on top is 1 larger than degree on bottom. Let's say it was like 2x cubed plus 1 over x squared plus 2x, right? This is a slant. Degree on top 1 greater than bottom. You do long division, okay, and then the quotient is the slant asymptote, and you want to ignore the remainder. Okay, that is those are how slant asymptotes work. Okay, y and x intercepts. Y-intercept's easy, just f of 0, right? Always for y-intercept. Okay. X-intercepts, you set numerator equal to 0, but you ignore the wholes. You know what I mean? So what I mean by that is you cancel, like, -2 is not a 0 in this example. You have to cancel that. We're going to do an example of this in a second. So you set the numerator equals 0, you ignore the wholes. Let's graph it. So x squared minus 4 over x squared plus 2x. Okay. You want to factor top and bottom first. So this is x plus 2, x minus 2 over x plus 2. Okay, so wholes. See, we got a same factor top and bottom here. That means we have a whole at -2. So we're going to cancel these two out and then plug in a -2 to what's left over. We would have -4 over -2, which is just 2. So we have a whole at -2. 2. Okay. The vertical asymptote, again, is when a 0 only the denominator. So the vertical asymptote is only at this x, so it's x equals 0. We have a vertical asymptote. Do we have horizontal or slant? The degree top and bottom is the same, so that means you just take the ratio of their coefficients, which is just 1. So we have a horizontal asymptote at 1. Y-intercept, we're just going to do f of 0. That's going to be -4 on top and 0 on the bottom, so it's undefined. There is none. Okay, and that makes sense because we have a vertical asymptote at x equals 0, right? And then the x-intercept. So we set the numerator equals 0, ignoring the whole. That means that only x minus 2 equals 0. that means just x equals 2. So let's sketch. So x equals 2 right there. Vertical asymptote right here, going up. Hole at where? Hole at negative 2, 2. So 1, 2, 1, 2. Open hole there. That's what I've got right now. Oh, and then a horizontal asymptote is y equals 1. Okay. So when it comes to asymptotes, the function always approaches them either as it goes to infinity or negative infinity, or as it goes to a specific value. So like from this hole right here, I know it's going to approach this just like that. It's going to go up towards, like, it couldn't go to negative infinity, because then it would have to cross the x-axis, and I know it doesn't cross the x-axis, so that's why I know it's going to go up here. And then likewise going left, like, it's got to approach this horizontal asymptote as it goes to negative infinity. So that's how I would draw that one. This one, again, I know how this is going to look. Like, I can see, all right, as it goes to the right, it's going to approach this, and as it goes to the left, it's going to approach negative infinity, right? When it comes to testing the points, that's just like what I showed you before in the number line. You would put, like, 2 would be on the list. Sure, 0 can be on the list. And that's pretty much it that I would include. And then you just test points that are to the right or in between these values to see if it's going to be positive or negative. So you plug in a 10, you're going to get positive. So you know it's going to be positive after 2, which it is. Anything between 0 and 2, like a 1, we're going to get negative on top, positive on bottom, so it's going to be negative between these two, which it is. And then anything below 0, like negative 10, we are going to get positives for both top and bottom, so it's going to also be positive. And that's what we have, right? So this just confirms what I have here. Again, like most of the time you can get it through just intuition and like connecting, oh, like I know this is above the x-axis and it can't cross the x-axis, so it could never be negative here. So it has to, or you can use the number line and test the points. Okay. X plus 2 over x squared plus 4x, same idea. We're going to factor top and bottom. X plus 2, we're good. And then x plus 4 on bottom. There are no holes here. Okay, so there's no holes because there's no factors that are the same. We do have 2 vertical asymptotes. We have one at x equals 0 and one at x equals negative 4. We don't have a slant. We do have a, so checking the degree of top and bottom, the bottom wins. That means our horizontal asymptote is going to be at y equals 0. Y-intercept, so f of 0. Well, we already know it's undefined because I have a vertical asymptote, so it's undefined. So we don't have a y-intercept. X-intercept, I set that numerator equal to 0, so x equals negative 2 is going to be my x-intercept. So here, that's negative 2. Let's plot what we've got. Y equals 0. Okay, so okay, that means like in the long run it should be approaching this. What else we got? Vertical asymptotes at 0, so right here, and at negative 4, 1, 2, 3, 4 right here. Okay. So this one's like a little bit tougher to sketch because I don't know if it's, like, I don't know what's going on here. Is it going up to infinity or down to infinity here? Like, I know it's, or it could be potentially doing both to negative infinity. I don't know what's going on. So we got to test that, and then test this side and test this side. So let's put it up. We're going to have all the vertical asymptotes and all the zeros in the number line. We're going to have 0, we're going to have negative 2, and we're going to have negative 4. So anything above 0, like 100, if I plug 100 in, it's going to be positive, right? It's going to be positive. 100 over, it's going to be positive numbers. That means that it should be approaching this infinity and then approaching 0 as we move to the right. between -2 and 0, so like -1. If I plug a -1 in here, I'm going to get positive on top, but I'm going to get negative on bottom, so it should be negative between these two, which would mean that it's approaching negative infinity, like this. Between -2 and, so -3 goes in, we're going to get negative on top, and negative on bottom. So it's going to be positive. So that would be going, so it means it's approaching this infinity. And then anything below -4, so like a -10, we're going to get negative on top, but a positive on bottom. So negative on top, a positive on bottom, which would make it negative, which would mean that it would have to approach negative infinity here, but then 0 here. And that's it. So that is chapter 3.